All right, so in order to, now in the past what I've said is you have the point estimate plus or minus your margin of error, right? Now, we can do the plus or minus because why? Because our z distribution and our t distribution are both symmetric, right? Well, the problem is that does not work for the confidence interval because I'm going to teach you a new distribution called the chi-square distribution.
Oh no.
Okay?
Ew.
Now, it looks like a script X. It's the Greek letter chi. It's not Chinese, it's Greek chi. I'm going to take a point off of anybody's quiz who calls it the chi distribution. Okay? It's Greek. Okay? So the formula for the chi-square distribution is n minus 1 times s squared over sigma squared. Okay? So it's a nice simple thing, but, oh, and also like the t distribution, it also has degrees of freedom equal to n minus 1. Now, later on in the semester, I'm going to give you a new degrees of freedom rule for the chi-square, but we're sticking with it for now. Okay? Marissa didn't like that.
You like teaching this class.
Okay, what'd you say?
I said you like teaching this class.
I do like teaching this class. I like torturing you guys all. Okay, so let's talk a little bit about some of the properties of the chi-square distribution. Okay? So the number one rule is it is not symmetric. And you guys are going to find out how awful that is in just a few minutes. Okay? Number two is the shape changes dramatically based on your degrees of freedom. And number three, as you can see from the squaring part of this, the chi-square is always positive or zero. It could be zero technically, but yeah, zero or positive. Okay. All right, so let me show you what I mean when I say that the shape changes dramatically. So here I have a picture of a bunch of different chi-square distributions. Now I don't know why they put a K there, but they did. That's actually your degrees of freedom. For 1 degree of freedom, it's the gold line. It goes like this. For 2 degrees of freedom, it's the green line. It goes like that. For 3 degrees of freedom, it no longer starts at the top, it starts at the bottom. And it goes like that. 4 is the blue line, 6 is the purple line, 9 is the red line. It really changes, okay? It changes and it's not symmetric, okay? All right, so, let's talk a little bit about the requirements. So just like your other confidence intervals, in order to do a confidence interval for the standard deviation or the variance, the requirements are, number one, it needs to come from a simple random sample, just like all the others. And two, so it's kind of funny because even though it's chi-squared, your population must be normally distributed, okay? And in fact, we're more strict on this confidence interval than we are on some of the other ones. The other ones we can get away with a little bit more. But this one's more of a strict requirement. So, yeah. All right, so remember I said you can't use the plus or minus idea anymore. Okay, you're gonna hate this. But here we go. Here is your formula. So chi-squared is between n minus 1 times s squared over chi-squared on the left and n minus 1 s squared over chi-squared on the right. Okay, you'll notice those are backwards. The left is on the right and the right is on the left. Okay, also notice, what do they give to you? What is that? The variance. So how would you find the standard deviation? Take the square root of everything, okay? Sometimes, so you need to pay attention, sometimes I'll ask you for the confidence interval for the variance. Sometimes I will ask you the confidence interval for the standard deviation. It's as simple as just adding the square root into it, okay?
So
Catherine had a question. You're good.
So you take the
You
square
just
root of both?
this, you just square root that.
Okay, you just take the square root of
Big
everything.
square root of everything. Okay? All right, so,
Wait, can you say that again? So did you say that r squared is the variance, is that what you said? In the middle?
say what?
Your sigma squared.
Are you calling that R?
Yeah, that's
a sigma.
Sigma, is that,
That's a really fat R.
is that, the variance, is that the variance?
That's the variance.
Okay, and the other one was what?
So if I get rid of that,
Uh-huh.
if I get rid of that, then I would square root, that would be the standard deviation.
Okay.
Okay? All right, so let's talk a little bit about the chi-square distribution, okay? So you're all familiar, you've got the z table there, you got the t table there, and you have the chi-square table, okay? Now let me show you down here at the bottom. Okay, so this chart shows you, now notice this has your alpha, it shows you the area to the right, okay? Now, in the past, we've said alpha over 2. This was actually Marissa's question at the beginning of the class. This is the one where we do 1 minus alpha, okay? So here's what I mean. Let's just do an example here. So, where's my example? Okay, so let's say that I want to find a 90% confidence interval for the population standard deviation for 3-year-old Chevy Corvettes. Okay? And I have the following data: 41,844, 36,995, 41,995, 36,995, 41,500, 40,990, 38,900, 43,995, 39,995, 37,995, 42,995, and 35,950. Okay? So I've just given you some raw data. What do you think you'd want to find out right off the bat? Probably the mean and standard deviation. Okay? And technically you don't need the mean for this, but you know, it's a Corvette. I don't know how much it was. So average of that, see the mean Corvette value is about $40,000. The standard deviation is 2,600. Okay? All right. So, in order to do the confidence interval, what am I going to need to know according to my formula? I need to know my n, right? How big is my n? Now if I count those up, I get 12. So I'm also going to need to know my degrees of freedom, which is going to equal 11. Oops. I'm going to need to know my s squared. I can do that. I've got my s. That's good enough. And now I need my chi-squared on the right and my chi-squared on the left. Okay? So let's talk a little bit about that. So typically, okay, now I know I told you that those change drastically, but typically, kind of what they drew at the bottom is kind of how it looks, okay? So I've got my thing here, it's not symmetric at all. Now, with a 90% confidence interval, what do I want? I want 90% in the middle, right? I want 90% here. Okay, which means how much do I want in that tail and that tail? 5. I got 5% here, and I got 5% here. Okay? All right. So I've got to figure out what these two values are. Now remember, just as a reminder, they're always positive. We don't have a plus and minus like we do with the P or the Z. And it's not symmetric. Okay, so here's what we got. So notice here, looking here, this is my alpha, okay? In my case, I want 5% on the right, okay? So if I pull this down here, okay, I want 5% on the right. I've got 11 degrees of freedom. That gives me that value, 19.675. So this value here is 19.675, which means I put it on the left over here. Okay? It's on the right here, it's on the left here. Really easy to confuse. So here's what I'm going to tell you. It doesn't really matter what if you mix these up, it doesn't really matter. When you get done, just remember you put the low number and then the high number in your confidence interval and you'll be all set. Okay? I mix them up all the time and then I just go, oh, put them in order. Okay? Always low number, then high number. Okay, so now this tells you what's to the right. If I want 5% to the left, what percent do I want to the right? I want 95% to the right. Okay? So now, so I just looked at the 0.05 column, now I'm going to look at the 0.95 column. Okay? So the 0.95 column, 11 degrees of freedom, gives me 4.575. So this number here is 4.575, which means that that number is also 4.575. Now, like I said, it doesn't really matter if you mix these up. It's really easy to mix them up, and I mix them up all the time, even did it in my first class today. Just remember low number, high number after that. Okay? All right, so now that I've got those numbers, okay, so I can need my lower and my upper. Okay. So according to this, my n minus 1, which happens to be the same as my degrees of freedom, is right there. I'm going to multiply that times my s quantity squared. And I'm going to divide that by, in this case, 19.675. Okay? So that gives me a really big number. Okay? Then I say, okay, I'm going to take n minus 1 times my s quantity squared, and I'm going to divide that by 4.575. Okay? Now what did I just find? This is my confidence interval for the variance. Okay? I asked for the standard deviation. What do I need to do? Square root of that number and that number. Okay? So essentially what I've done here, okay, if I draw this on here, I'll pick a different color, okay? So those are my values. Okay? So I got a value, so my standard deviation was about 2615, okay? On the low side, it would be 1955. On the high side, it's going to be 4055. Now notice here something. This number is much closer to that number than it is to that number. Why is that? Because it's not symmetric. Okay? It's not supposed to be symmetric. Okay? Who misses symmetry already? Okay? So this one's going to be a little bit goofy. Yes?
I just missed that you got the 4.575.
Okay? All right. Good question. Okay? So once again, I want 5% on the right, I want 5% on the left. Did you understand how I got this number?
Yeah.
Okay? So this only tells me what's to the right. If I want what's to the left, how much, so if I want 5% on the left, how much is to the right? 95%. Okay? So I'm looking at the 0.95 column. So these are the two columns, 0.05 and 0.95. 0.95, 11 degrees of freedom, 4.575. Okay?
So it tells you area to the right.
It always tells you the area to the right. Okay? Make sense? Okay.
Will you explain what the red numbers mean, like 2615, is that the standard?
That's your standard deviation.
Okay.
Okay? And I'm 90% confident that the mean, excuse me, I'm 90% confident that the standard deviation is between $1,955 and $4,055. Should have had you guys interpret that. Okay, what if I ask you, is there a 95% chance, I do this in my other class, there's a 95% chance that the standard deviation is between 1955 and 4055. Okay? In my other class, they like to make you interpret confidence intervals. And I always tell people, anytime you hear the word chance, it's wrong. We don't know what the chance is. We only know that if I did this 100 times, 95 of my confidence intervals would have contained the true value, and 5 of them probably wouldn't.
We round up in this scenario, like you either get decimal or you round up.
Well, these are, I rounded to the nearest dollar.
Okay.
So typically, yeah, I would go one more decimal than they are, but yeah, I'm not going to be too picky on that. Okay? All right. Gosh, we're like 5 minutes early there. Let me do this. Let me just mention this. Okay, Monday, we're going to start on chapter 10. We're going to do 10.1. Okay? Chapter 10 deals with hypothesis tests. It's probably the most difficult topic we're going to cover. Okay? I'm going to try to give you an overview on Monday. The good thing about Monday is I'm not going to make you do any math. Okay? So there's no calculations you're going to have to worry about on Monday. The bad thing is you're going to have to interpret. And that's where everybody has a problem. Okay? So I'm going to really help you with that. So I'm giving you the weekend to study chi-square. I would encourage you to kind of get started. We're only going to cover chapter 10.1 on Monday. Tuesday, I'm going to do a review. Tuesday, you can also take the test, the computer part of the test in the testing center. Tuesday or Wednesday in the testing center. Wednesday, we will do the in-class portion of the test, the written part of the test. Okay? Question?
That was the first part of my question. The second part is what sections will include?
So I think we started chapter 7, didn't we? So 7 through 10.1. That's what I believe we're going to cover.
Will we use like the computer part in the testing center? Will we have the computer parts in there?
Yes, I've already dropped them off. Okay. So, any other questions? No time limit in the testing center. Okay? You can take 8 hours if you want. That's a good question. You can't take longer than the testing